Yes, hello grade 12. Good morning once again. It's Patrick Kamala, tutor educator, mathematics and physical sciences. Yeah, we can teach you online, one-on-one, or you can join us in the group. Now, after doing video 1, question 1 and 2, now this is video 2, and we are doing question 3. Memorandum 2025, Mathematics P1 Grade 12. Yes, this was question 3. It says that the depth of a torpedo below sea level forms a quadratic pattern where 0 meters is at sea level. A submarine tracked a torpedo in 1 second intervals. I repeat, the depth of a torpedo below sea level forms a quadratic pattern where 0 meters is at sea level. A submarine tracked a torpedo in 1 second intervals, which means every after 1 second, it's tracking another torpedo. Okay, so they say that the depth in meters that the torpedo reached is given in the table below. Okay, so this is the depth here in meter, that is 36. At the end of the first second, it is 36 meters below. At the end of the first 2 seconds, 71 meters below. At the end of the first 3 seconds, 104 meters below. They say calculate the depth of the torpedo at the end of the first 5 seconds. Now they said it is quadratic. Okay, it forms a quadratic pattern here. They're telling us mean that we are going to be having a second constant difference. Okay, so in that matter, yes, let us see what they want here. Question 3.1. Okay, so by the end of the first second, you can see this is our T1 here. Okay, and then T2 of the second, then T3 end of the third second. Okay, you can also say, yeah, T4 and T5. Okay, now at the end of the first second, the meters were how many? 36 meters. Okay, at the end of the 2 seconds, how many meters were they? 71 meters. At the end of 3 seconds, they are 104 meters below the sea level. Now, because they said quadratic, we go ahead to do out what we wanted. Now, T2 minus T1, what do you get, calculator? We get 35 here. And then T3 minus T2, 104, okay? And being quadratic, we need to find a second constant difference, because they say calculate depth of the torpedo at the end of the 5 seconds. So I'm looking for this T5, right? So in here, now 104 minus 35. Okay, I beg your pardon here. If I say 104 minus 21, what do I get? I'm getting 33, okay, 33. And then now 33 minus 35 is -2. Now, being a quadratic pattern, you've got this constant second. Meanwhile, we say if you say 35 minus 2, you get 33. So I'm going to say again 33 minus 2. What do you get, guys? You get 31. Okay. And then to get my next term here, which is T4, I just say that 104, okay, plus 31. What do I get? I get 135. Okay, 135. And again, I'm going to say now 31 minus 2, because it's quadratic, I get 20 what here? I get 29. Now to get my T5, I'm going to say 135 plus 129. What do you get? Here, it gives me 164. So the answer here, which they want, is 164. So the T5 is 164 meters below the sea level. Okay, 164 meters below the sea level. So they say show that the depth of the torpedo at the end of the n seconds is Tn equals to minus n squared plus 38n minus 1. Now, being quadratic, what do we know? What do we know being quadratic? We have a second constant difference, which we call D2. This is our D2 here. Our first difference, which we call D1, that's 35 here. And then the first term was 36, which is T1. Now we know that because it is quadratic, our Tn equals to an squared, okay, plus bn plus c. So our task is to find a, b, and c. It must be like this, okay? So now remember that being quadratic, twice the second difference, twice a gives us the second difference. Ne? The 2a give us what? The second difference. The 2a give us what? D2. What's our D2 here? Negative 2. So divide by 2, our a is negative 1. After getting a, we also know that our 3a plus b, okay, 3a plus b should give us our D1, okay? Now our D1 is this 35 here, so I'm going to say here 3a, but the a now is negative 1, and then plus b. The b is what I'm looking for. Now my D1 is what you guys see here, 35 here. Now 35 plus 3, I get b as what? As 38. Ne? Okay, then to get my c, I use my T1 number using a plus b plus c. A plus b plus c equals to T1. So here, what do we do? Substitute again. We know that our a is negative 1, right, guys? Our b is 38. And we are finding what now? We're looking for the c. But our T1, as you can see, it is 36, ne? Equals 36 here. Okay, so now tell me 38 minus 1, 37. And the 36 minus 37, that's negative 1. So our c, negative 1. So therefore, our Tn is given by what? Tn equals to our a, that's negative 1n squared, okay? Negative 1n squared. Then our b, it is 38, so plus 38 here, plus 38, and our c is minus 1 as required. So hope we are together, guys. Then next, I say here that calculate the maximum depth that the torpedo reached. Calculate what? The maximum depth the torpedo reached. Now, being being quadratic, this one is parabolic. Okay, as you can see, our a is negative, so it means that if you sketch this quadratic here, or this parabola here, would be something like this. Okay, if we had sketch it, it would come like this. I think I can clean up this now. I don't need it. Okay. Oh yeah, they're saying here that maximum depth that the torpedo reached. So now being a negative 1 here with our a, this is the shape of the parabola, and the maximum is happening here. Okay, it's happening here. And being parabolic, we see this is a turning point here where our derivative is equal to 0. So we can differentiate this expression here. We can differentiate it here and equate to 0 because now at maximum here, our t derivative, okay, equals to 0. Okay, so now differentiate here, you get what? You're going to get here minus 2n and then plus 38. Okay, then it must be equated to 0 now because of the turning point here. So now our 2n, all our 38 equals to 2n divided by 2. So our n is what? Is 19. So mean that after 19 seconds, that's when we get our maximum height. But because we're looking for the maximum height itself, we're going to say our T19, then substitute in here, we're going to say negative 19 squared, okay, then plus 38 times 19, and then they said minus 1. Okay, so calculators here, what do you get here? And calculators, here I'm getting 360, okay, 360 meters below the sea level. Now that's maximum height for this torpedo below the sea level. Now they say here that after how many seconds was the torpedo at 104 meters below the sea level for the second time? Now if you check here, 104 is after 3 seconds, but for the second time, being a parabola here, we know that if I may put this line here, which you guys see in blue, this one here, mean that being a parabolic here. Now the first time, remember this shows us the depth of the torpedo. Now here, this was our t equals to 3 seconds here. Okay, this one here, 3 seconds, which you see here. That's what you see here. Our t equals to 3. Now they want another time when it is also going to be the same height of 104. So I'm looking for this t here. So in other words, I'm looking for the n when my height is 104. Okay, so I'm going to say, I know that the Tn equals to minus n squared, okay, and they said plus 38n and then minus 1 now must be equal to what? To 104. So here I'm going to form the quadratic. I'm going to say minus n squared, then plus 38n, okay, now minus 105, right? 105 now equals 0. So in here, now I'm quadratic formula here. If I substitute in the quadratic formula, I'm going to get n equals to negative 38, okay, then plus or minus square root of b squared minus 4ac, that is 38 squared minus 4ac. Our a is negative 1. What about our c? Negative 105, okay, then divide by 2a, our a is negative 1 here. Now calculators here, what do you get? Calculators, what do you get? Now from my calculator here, I'm getting my n, if I use a plus, n equals to 3 or n equals to 35. So the question said that how many seconds to get this height again? So it's going to be after 35 seconds, meaning that T35 is when we get that same height of what? 104 meters. So answer is after 35 seconds, okay? All right, let us proceed.